All right, in this lesson we are talking about sequences and specifically arithmetic sequences. And so to warm up, we're just going to look for a pattern in these following sequences. A sequences is just a list of numbers in a specific order. So my first example, I have 1 going to 4, going to 7, going to 10, going to 13. So you may notice that we are adding 3 each time. And so that would take us to 16, then 19, and then 22. Okay, in this next sequence, we're going from 4 to 8, 8 to 16, 16 to 32, 32 to 64. So in this case, we are multiplying by 2 each time. And so that would take us to 128. And then I don't know what 128 times 2 is. 256, and so on. Okay, this next example, we're going from 7 to 2, 2 to -3, -3 to -5. So we are subtracting 5 each time. So that would take us to -13, -18, and then -23. Okay, and so when we're talking about a sequence, we're always looking for some nth term, and that term is denoted by a sub n. Okay, and so when you're trying to find a term, so if I want a sub 2, I'm looking for the second term. If you see a sub 100, I'm looking for the 100th term. Okay, and so arithmetic sequences are a specific sequence where we have a constant difference, which means we can only add or subtract. Okay, only addition and subtraction. And so number 1 would be arithmetic, and number 3 would be arithmetic. Number 2 would not be arithmetic. It's actually a different kind of sequence we'll talk about, but because we're multiplying, it is not arithmetic. There are 2 forms of arithmetic sequences that we can write the equation for. We have recursive form, and then we have explicit form. Both are standards to be able to write in recursive and explicit form, so we'll talk about each one separately. And then the change between the 2 consecutive terms is called the common difference. The common difference. And so we denote that with D. Okay, so in this case, our common difference is 3, so we would say D equals 3. In the case of number 3, the common difference is -5. That's the number we're adding each time. Okay, so recursive form only allows you to find the next term. So it's not as useful as the explicit form because recursive form depends on the previous term. Okay, so a sub n, just view that notation to mean any term. Okay, and then anytime you see an a sub n minus 1, these are subscripts, it's just referring to the previous term. So it's kind of scary notation, but just read it as you can get to any term by taking the previous term and adding D. And so D, of course, is the common difference. And so in recursive form, it's not really a formula that's helpful. It's more just telling you what the pattern is, okay? And so looking at number 1, it says you can get to any term by taking the previous term and adding 6, okay? So if I want a sub 3, I'd have to get a sub 2. And a sub 2 is found by taking the previous term, a sub 1, and adding 3. Well, we know a sub 1 is 3, so if we add 3 to that, we get 6. Okay, so now if I want the third term, I have to take the second term and add 3. We just found out that the second term is 6, and so I would have to take 6, and add 3, and then I would get 9. So if I was writing this sequence out, my first term is 3, my second term is 6, my third term is 9, and you can keep going by just adding 3. And so you can see a sub 1, a sub 2, a sub 3. And so they wanted a sub 3, and so we can tell them it's 9. Okay, this next example says you can get to any term by taking the previous term and subtracting 5. Okay, so if A1 is 45, that means A2 would be the 45 minus 5, which is 40. And then A sub 3 would be that 40 minus 5, which would give me 35. Okay, and they want A sub 5, so we're going to keep going. A sub 4 would then be the 35 minus 5, which is 30. And then A sub 5 would then be the 30 minus 5 equals 25. Okay, so if you're looking at the sequence, it starts with 45, and we just keep subtracting 5. So if you want to write it in list notation to make it easier, either way would be fine. You just need to know you're looking for the 5th term. Here we have the 1st, the 2nd, the 3rd, the 4th, the 5th. And so your answer for this question would be 25. Okay, on number 3, it says you can get to any term by taking the previous term and adding 7. So I'm going to write it in list notation because some people prefer that. So here's my first term, and then I just need to keep adding 7. So negative 24 plus 7 would be negative 17, plus 7 would be negative 10, plus 7 would be negative 3, and that's all they wanted. They wanted A4, and we just got to it, and so we would answer negative 3. Okay, so now it says determine if the following sequences are arithmetic or not arithmetic. If the sequence is arithmetic, identify the next 3 terms and the common difference. Okay, so looking at 4, I added 3 again, added 3 again. So this is clearly arithmetic. And so 17 plus 3 would be 20, plus 3 would be 23, plus 3 would be 26. So my common difference is D, and this is arithmetic. Okay, to get from negative 4 to 1, we would have to add 5. To get from 1 to 6, we would add 5 again. To get from 6 to 11, we would add 5 again. And then to get from 11 to 16 or 17, we would add 6. And so that 17 messes up our sequence. But if it was a 16, I'm going to change it because maybe it was supposed to be. I'm going to change it into a 16, and then this would be arithmetic. And so D would be 5, and this would be yes. And to get our next term, 16 plus 5 would be 21, plus 5 would be 26, plus 5 would be 31. Okay, in this next one, we are subtracting 10, subtracting 10, subtracting 10, and so we can keep going by subtracting 10, and this would be arithmetic with a common difference of negative 10. All right, so explicit form is the form that we prefer to find any term. Because if I'm looking for the 100th term, I really don't want to go through this whole process. Even getting to the 5th term was kind of annoying. And so if you could imagine trying to get to the 100th term, and so that's when you would want the explicit form. Okay, and so the explicit form says you can get to any term by taking the first term and adding D n minus 1 more times. So for example, if I want the 10th term, I would take the first term and add D 9 more times. Because think about it, we're trying to get to the 10th spot, so we would just keep adding that D value. So remember, A sub n still represents any term. A sub 1 is your first term. N is the term number. And then D is still the common difference. Okay, so in order to have an explicit form, they have to tell you the first term and they have to tell you the common difference. Okay, and so these next example says use the arithmetic explicit form to find the following nth terms of the following sequences. Then write the arithmetic recursive form. Okay, and so looking at number 1, it looks like we are adding 4 each time. And so in recursive form, that's the one that depends on the previous term. We would just tell them, take the previous term and add 4. That really just tells you the pattern. It's not a useful formula. But the explicit form says we take the first term, which in this case is 8, and we add the common difference, which in this case is 4. And we would do that n minus 1 more times. Okay, so specifically for A10 would be the 8 added 9 more times, or 8 plus 4, 9 times. And so 4 times 9 is 36. 36 plus 8 is 44. Okay, in this next example, we are subtracting 6. So I can see that D is negative 6. So in recursive form, any term equals the previous term minus 6. In explicit form, we take the first term, which in this case is 36, and we add the D value, which in this case is negative 6. So I'm going to do minus 6. N minus 1 more times. Okay, and so for A8 in this case, we are taking 36 and subtracting 6 7 times. And so that would be 36 minus 42, which would be negative 8. Negative 6. Okay, here we're finding A20, so it looks like we are adding 5 each time. So our recursive form would be any term equals the previous term plus 5. Our explicit form would be the first term plus 5 and minus 1 more times, since our D in this case is 5. Okay, so here they want A20. That would be really annoying to find using the recursive form. But now we would just put 19 in those parentheses. So we would take the 4 and then 4 plus 5 times 19. 5 times 19 is 95. And then plus 4 would be 99. Right, number 4. They're telling you your first term is negative 10 and your D value is 5. So in recursive form, we would just say add 5 to your previous term. But in explicit form, they told us the first term. They told us D, which is 5, and we just put that n minus 1 next to it. So here they're just explicitly giving us those values. We just need to set up our formulas. Okay, so to find A7, we add 5 6 times. It's always n minus 1. So negative 10 plus 30, which would be 20. Okay, here, our first term is 4. Our common difference is 8. And so that means we get to any term by taking the previous term and adding 8. That's our recursive form. So for our explicit form, we start at the 4, that first term, and we add 8 n minus 1 more times. So specifically for A25, we would take 4 and add 8 24 times. It's always one less. Okay, and so 8 times 24 is 192. Plus 4 is 196. Okay, this next one, our first term is 10. Our common difference is negative 6. So my recursive form would just say take the previous term and subtract 6. My explicit form would say take the first term and subtract 6 and minus 1 more times. Okay, and so for A5, we would take the 10 and subtract 6 4 times, which is 10 minus 24, which is negative 14. All right, if the fifth term of an arithmetic sequence is equal to 23, I'm going to write that down, A5 is equal to 23, and the sixth term is equal to 27, what is the first term of the sequence? What is the common difference? Okay, so here we have consecutive terms, and so we can see that we added 4, so we can answer the common difference right off the bat. D equals 4, right? And then if we want to find the first term, I like to use the explicit formula, which says you take the first term and add D n minus 1 more times. And so let's just use, we can use either of these. I'm going to use A5. I know that the value of A5 is 23. I don't know the first term, but I know the common difference is D. And I know for the fifth term, I have added that D value 4 more times. And we know D is 4. I should have written 4. Okay, and so that means 23 is the first term plus 16. We can subtract 16 from both sides. And 23 minus 16 is 7, negative 7, positive 7. So our first term is 7. Okay, and so our first term is 7, our common difference is 4. And then let's just check that because I'm not sure. So A1 is 7, and then if we keep adding 4, that would take us to 11. Plus 4 would be 13, 15, plus 4 would be 19, plus 4 would be 23, plus 4 would be 27. And so if we look at this, A2, A3, A4, A5, A6, so A6 is in fact 27, A5 is in fact 23. Okay, number 8, if the 10th term of an arithmetic sequence is equal to 75, and the 12th term is equal to 89, what is the first term of the sequence in the common difference? So here we don't have consecutive, so I've added D twice to get to the 89. And so we can think of that as 2D, D plus D equals the 89. And so if I subtract 75 from both sides, and then divide by 2, I can see that D is 7. Okay, and so now to find, we can use either term to find the first term. So for A sub 10, we know we've taken the first term and added that 7 9 more times. Okay, and we know that A10 is 75. And so 75 equals the first term plus 63. And so if we subtract 63 from both sides, we get 12 for our A1.